Greetings and welcome to Raven's Roost Forge. This is Tate, your host, and today we're going to heat treat and hand finish the blacksmith knife. Let's get started. So in the last video we had finished up the forging process, and now we need to finish the knife. And we need a secure way to hold it down that's not going to allow it to twist or move. So I've taken a piece of wood here and I'm just using a rasp to kind of file a notch into it, and then that will allow the finger guard to fit into the notch and the blade can rest against the piece of wood, and then we can clamp it down. Now this doesn't need to be fancy, it just needs to allow us to clamp the knife securely, so that notch doesn't need to be anything special. So you can see what I've done here is just clamp the knife down with a C clamp and then clamp the block down with an F clamp. And now I'm using a black marker to just lay out where I want the bevel to terminate on that knife. Now we already forged in that bevel, so we've already got it started. But what I want to do next is file the bevel in, and I'm just using an abrasive disc to remove the scale first, because the scale will dull my file teeth very quickly if I try to use the file to remove that scale. So I'm just going very lightly with a abrasive disc to get rid of that scale. I started at the very edge and then I'm working my way back so that I don't go back too far and go beyond my layout lines. You don't want to go beyond the layout lines because then we're going to end up with bare metal where we want a forged finish. Now we want to remove the scale on both sides. You can do that now or later. And then you want to clamp the knife back in, and then we're going to use a file in order to finish off that bevel. And this technique here that I'm using is called draw filing, where you draw the file back and forth perpendicular to the length of the steel, which is a little different to the filing technique that most people are used to. And it works really good if you want to get a more flat, uniform finish, which is very hard to do when you are pushing a file the normal way. Now here I'm using the flat side of a good quality, coarse, half-round file, but you can use any flat file for this. You want to start with something that's coarse, like a bastard file, otherwise it's going to take you forever. So what I want to do is get a nice, flat, even primary bevel, and I want to get down to bare metal across the entire bevel, and you can see that I have now, and there's a little bit of forge finish left. What I'm doing here is just putting a little white on the edge so that I can kind of see a little better the thickness of that edge when I work on the other side of that bevel. I'm just going to do the same process on the other side, and I'm just going to fast forward really quickly through that so that it's not so boring. I do think it's a little bit neat to see the transition from scale and hammer marks to a clean, bright finish this fast. So now we've got both sides of the knife taken to the same level. And now I'm just using a hook rule to make sure that the bevels are the same width, or at least roughly the same width. We can fine tune that later with the hand sanding, but they've got to be close. And then I'm going to go from file finish to 100 grit finish, and that'll be the final stage before we go ahead and do the heat treat. I do think it's fairly important to get the largest scratches out of the blade before you do the heat treatment, because they can act as stress risers and increase the likelihood of cracking. And so I usually try to make sure that any scratches larger than about 80 grit I get rid of before I do a heat treatment. I'm really going to fast forward through this process as well, because watching a hand sanding is almost as boring as doing it. It really is the biggest slog of any knife making project. The sanding block I'm using here does have a leather strip attached to it, a thin leather strip, and that allows you to get a finer finish a little bit quicker because it accommodates slight irregularities in the surface better. There's a tiny bit of convexity in this bevel, and I don't mind that, but if you want to get yours absolutely flat, you're going to need a really flat steel sanding block. And then of course we've got to flip it over and do the same thing on the other side. Of course, it's exactly the same process, so I'm not going to show you all of that. Next thing we need to do is finish off the handle. We rounded over the edges and everything before we curved it, but now it's got more scale on it. It's got a little roughness, so we need to smooth that out and make it nice to hold. I started with a nylon abrasive brush in the handheld drill to get into some of these nooks and crannies, and it does work, but it's slow and it's extra tedious. So pretty soon I switched to a conditioning disc on the angle grinder, and this is a lot more aggressive and gets rid of that scale and roughness a lot quicker. This is one of those paint stripper discs, and they work really good. They're very aggressive but still leave a pretty good finish. And just make sure you wear your respirator. It's not so important when you're hand sanding because you're not kicking up a lot of dust, but when you're using power sander like this, then you're getting a lot of grit thrown up into the air, and you're also getting a lot of resin and so forth from the disc itself, and that's just no good on your lungs. Take your time on this part. Take the knife out frequently, hold it, see how it feels. Make sure that you get rid of all the irregularities and the roughness, because if you want to be able to actually use this knife, you want it to be comfortable to hold. Otherwise, you're not going to want to use it, so you don't want to skimp on that part. So now everything is finished to a reasonable degree, and we're going to go ahead and do the heat treatment. So you can see I already have a nice fire built up with a bank of coals, and then I'm going to take a steel block and just set it up over the fire along with the quenchant. This quenchant is just a mixture of paraffin wax and vegetable oil so that it stays solid until you warm it up a little bit. I find that that's really great for a portable quench. Now this is going to be an interrupted quench. I'm going to quench in the water first. So I'm warming up the water with just a random steel bar. This is the end of a pair of tongs that I never finished. And then from the water, after about 2 seconds in the water, we're going to go into the oil quench to cool off the rest of the way. Now this really reduces the likelihood of cracking or warping, and you still get the full hardness like you would if you quenched completely in water. Now, if you quench only in the vegetable oil, you will get a hardened blade. It's just not going to be full hardness. Trust me, I've actually done the experimentation, and in an upcoming video, I'll actually show you guys that. It's so much better to learn the interrupted quench method so that you can get the full hardness out of the steel. So this first heat here is just a normalization cycle. Normalization will improve the grain structure of the steel and will result in a tougher knife when you're actually done. We want to bring it up to non-magnetic, just above non-magnetic. You don't want to overheat. And then you're going to allow it to cool slowly in still air. And then once it's completely magnetic again, you could quench it if you like. And then we're going to go back in the fire, and we're going to get ready for the actual hardening quench. So I actually did 2 normalization cycles. I just showed one though. Now we're going spine down into the fire to get ready for the final quench. As soon as we hit non-magnetic, we're going to go into the water for 2 seconds. There we go. And then the rest of the time into the oil to get the rest of the cooling. And that's all there is to it. We got a hardened blade. We're going to check that in a second. To check the hardness, I'm going to use a hardness testing file. And in order to do that, you need a clean bare metal surface. We also want to sand through any little bit of decarburized steel that may be on the surface from the heat treatment. And then once we do that, we're going to use the hardest file in the kit, which is the 65 Rockwell file. And we're going to see if that actually scratches the steel. And it was barely even making any kind of a mark at all. So we know that we're very close to 65 Rockwell on that. Next, we're going to draw back that hardness a little bit in the oven at a temperature of about 400 degrees Fahrenheit, about 200 degrees centigrade. And we're going to do 2 cycles of at least an hour. I usually like to add about 10 minutes onto that time to make sure that the blade has already gone up to temperature before I start the timer. Get a load of that nice bronze color we got from the tempering cycle. That's a good indicator that we got the correct temperature. Let's go ahead and polish off those oxides, and then we'll retest the hardness and make sure that we drew it back enough. You can see I upgraded to a Subusan set, which is a much higher quality set of files. We're going to start with the 65 again, and it's pretty easy to get a deeper scratch with the 65. So we know that it's softer than 65 now. We're going to try the 60, and this one just scratches a little bit close to the base of the blade and hardly at all in the rest of the blade. So it looks like this is just under 60 Rockwell. So this step here is going to be completely unnecessary. I'd have a totally serviceable blade if I left it as is, but I'm going to go ahead and take the time to do a selective temper. So what I'm doing here is dunking the edge in water in a little steel dish. This is a magnetic parts tray that I just pulled the magnet off of. Next, I'm going to heat up the spine and the base of the handle and temper it back further. This will give me a softer, tougher spine and handle and a nice hard edge. And the water just keeps you from over tempering the edge. So you can see those temper colors creeping down the spine, but we're not actually tempering the edge back any further because the water is constantly cooling it. And so this is a way that you can get a good selective temper. So you can see a little more clearly here the temper lines. Everything below the line is the same hardness as it was before, around 60. And then everything above has been tempered back fully, and it's probably around 45 Rockwell. I want to make sure that the rest of the handle is also tempered back, especially the curve where it might receive some stress. And since it's not polished and I can't see the temper colors, I'm just using a toothpick to determine the temperature. A small piece of wood will usually start to smoke around 575 to 600 degrees Fahrenheit, which is about 300 degrees Celsius. So once you see it start to smoke when you touch it, then you know it's tempered back fully. And then I'm just gonna quench it off in order to make sure that it's not tempered anymore. I was really careful to make sure that I didn't heat up the blade too much and draw back the temper on it. But now we're ready to go ahead and polish it up the rest of the way. And I'm starting with 220 grit paper. And then I made a new little sanding block that fits the curve of the handle a little better. You can see that here. Sanding, of course, can be pretty boring to watch, and it can be pretty boring to do, honestly. So I went ahead and sped that up quite a bit so that it's not too boring. But it is worth noting here that when you are trying to get a good polish on a blade, you want to make sure that you get all the scratches out from the previous grit before you move to a higher grit. So what I usually will do is go long ways for one grit, and then I'll go diagonal for the next grit. That way the scratches are in a different direction, and if you have any stray scratches from the previous grit, you'll be able to see them. And it helps to use a high intensity light from a variety of different directions in order to make sure that you haven't missed any scratches. Make sure that you clean the knife off thoroughly when you flip it or move to another grit. Otherwise, you're going to get some grit contamination and you're likely to get some stray scratches. Hand sanding is always going to be a tedious process. Just keep that in mind when you're doing it. Take your time, make sure that you get all those scratches out from the previous grit, and you'll end up with a nice finish. If you try to hurry through it, it's just going to look like crap. The final grit should be done lengthwise to give the best look, and I only took it up to, I think, 400 grit here, and you actually will still get a really nice finish with only 400 grit when you do hand polish. Now that the polishing is done, it's time to actually sharpen up the blade. So I'm putting the secondary bevel on there with a diamond file. This is just an inexpensive diamond file made by Rigid, and I got it at Northern Tool. And this is normally used for like shaping tile and stuff like that, but it works perfectly for this hardened steel. This diamond file I think only cost me $10, so it's well worth it. But if you don't have a diamond file like that, you could use sandpaper on a sanding block. Even with a low grit though, that's going to take forever. The best way to do this is if you've got a belt sander, especially one of those little 1x30 belt sanders. Those are excellent for putting a secondary bevel on a knife. I'm just kind of eyeballing the angle here, but what I'm trying to go for really is an included angle of about 40 degrees 40 to 50 degrees. So that means the angle on each side of the blade should be about 20 to 25 degrees. Now this method is going to leave a really ragged initial edge, but you should still be able to use your thumb carefully to tell if you've got a burr, and that's an indicator that you've apexed the edge. And that's a really ugly edge to start with, but we'll clean it up. So this next thing that I'm using here is basically like a ceramic sharpening file. This is used for axes and lawnmower blades and stuff like that. I think it's equivalent to about 150 to 180 grit, something like that. And it's going to refine that edge quite a bit. It's going to get rid of all the raggedness of the edge, but it's still not going to be very sharp because this is still a pretty low grit. If you're a more patient person than I am, you could definitely use a sintered ceramic file like this to actually put the secondary bevel on in the first place, but it'll take a while. The last step is to actually put the final edge on this, and to do that I'm using a 4-sided diamond stone that I got from Harbor Freight. I think it only costs $10 or $15, and it has a 2, 3, 4, and 600 grit side, which even a 600 grit is not going to give you a super sharp blade, but if you combine that with stropping, you can get a really serviceable edge. And I'm trying to do this video obviously with inexpensive tooling that anybody could get a hold of easily. So I wanted to stick with that even with the sharpening stones, because you could spend hundreds of dollars on sharpening stones, but you can get a pretty good edge even with something like this that is cheap and only goes to about 600 grit. So all that's really happening here is I'm trying to maintain that correct angle as I sharpen the blade, and I'm just taking as many strokes as it needs in order to get a burr on one side of the blade, and then I'm cleaning it off and flipping it over, and then honing until I get a burr on the other side of the blade. I'm just using a little soapy water in a spray bottle to lubricate the stone, and then once I've gone all the way up to 600 grit and I've developed a burr on both sides, then I know I'm ready to strop. It can be easier to strop if you minimize the size of the burr, and you can do that by just doing a couple of strokes on each side of the blade on the final sharpening stone, and you just go back and forth a couple of times to reduce the size of the burr, and then you can strop. And when we're stropping, we're just impregnating a piece of leather that is on a flat piece of wood. We're impregnating that with polishing compound. I like using Tormek stropping compound, and then you try to maintain the same angle that you were sharpening with as you drag the edge away so that you don't gouge into the leather. And what that'll do is it'll slowly wear that burr away. When the burr is completely gone, the blade will actually feel a little less sharp to your thumb, but that just means that you've got a really nice smooth apex, and that's an edge that will last a long time. So now I've gotten rid of that burr, I've got a nice smooth apex, and it's ready to test out the sharpness. So I'm just going to shave a little hair off the back of my hand, and it does shave. It's not the sharpest thing that I've ever made, but this is a more than serviceable edge. Okay, now we got a nice sharp blade. The knife is pretty much ready. I'm just going to work a little beeswax and oil mixture into the handle, and this will improve the luster of the handle a little bit, and it will also protect it from rusting. And the knife is pretty much ready to go. So beauty shots coming up. Okay, so here's the final blade. I'm really happy with it. It's comfortable, it's usable, and that's the process of making a blacksmith knife from start to finish. So I hope that you enjoyed this video and you learned something. Don't forget to like and subscribe. I'll see you next time, and happy forging.